Here's a quick proof of the idea that the derivative of the inverse tangent of x is equal to 1 over the quantity x squared plus 1. I think it's also a good review of some trig concepts that people might have forgotten over the last couple of years. So you can see here I start out with the equation y equals the inverse tangent of x. And the first thing to remember is that since this is an inverse, the input and the output from a typical tangent equation have been switched. You normally take the tangent of an angle measure and you get back a fraction. The inverse tangent is being taken of that fraction and it's giving you back the angle measure. So essentially we're saying that y is the angle whose tangent is equal to x. Well, in that case I can rewrite that using the inverse idea, and I can basically say that x is equal to the tangent of y. And in this form I can actually set up an equation using my SOHCAHTOA rules. Tangent is equal to the opposite side over the adjacent side. So what that's telling me is if I take the tangent of this angle, I'm going to get the fraction x over 1. So I can actually label a triangle with that information. Y is really an angle measure. Okay, this is the angle whose tangent is x, or whose tangent is x over 1, if you want to look at it in that sense. Okay, tangent is an opposite over an adjacent side. So I can label my graph that way. My opposite side is x, my adjacent side is 1. According to the Pythagorean theorem, x squared plus 1 squared is supposed to equal the hypotenuse squared. And that means that my hypotenuse is the square root of x squared plus 1. So I want to label all sides using that x variable. Now I can come back and I can take the derivative. Okay, the derivative here, and keep in mind I'm going to be taking the derivative implicitly here because I'm taking the tangent of y. The derivative of x with respect to x, of course, is just 1. Technically I could say 1 dx dx, but that's really just 1. The derivative of tangent is secant squared. In this case it's tangent of y, so it's going to be secant squared of y times the derivative of the inside function. Remember, that's the derivative of y with respect to x, which is dy dx. At this point I want to solve for dy dx, so I can divide both sides by the secant squared of y. And I'm going to get 1 over the secant squared of y equals dy dx. Now, do I want my derivative written in terms of y? No. So I need to come over here and I need to find the value of secant squared of y with respect to x. Well, secant is the inverse, it's the reciprocal of cosine. Cosine is the adjacent side over the hypotenuse of a right triangle. That means that secant of y is going to be the hypotenuse over the adjacent side. Well, secant squared is the square of that value. It's going to be the hypotenuse squared over the adjacent side squared. Well, if I look at my graph up here, the hypotenuse squared basically is going to knock out my radical. That's just going to be x squared plus 1. The adjacent side squared is still just going to be 1. And so that means that secant squared of y, when I simplify this, is just going to equal x squared plus 1. That denominator really isn't needed here in this case. So I can substitute that back into my other equation over here, and I find out that dy dx is equal to 1 over x squared plus 1, and that is the derivative of the inverse tangent of x.